Good day, grade 12 learners. Welcome to today's mathematics lesson. My name is Tepang Mapotani. This lesson is brought to you by the Northern Cape Department of Education in collaboration with Pagama Research and Development. Now, grade 12, in today's lesson, we are turning our attention to our final preparation for our examination. So for this lesson, we are focusing on paper 1 revision. And the topics that we are going to focus on for this lesson is going to be algebra and equations, including inequalities. This topic weighs around 25 marks. And we will also focus on the topic of sequences and series. And also, this topic weighs 25 marks in our paper 1. Right. Now, by the end of this lesson, you must be able to identify and know that structure for paper 1. And we are going to focus on the following topics. We are going to focus on the topic of algebra and equations, including inequalities. And we'll also focus on the topic of sequences and series. Now, grade 12, this is our structure for paper 1. And we can see that our paper 1 has 6 topics. We have the topic of algebra and equations, including inequalities, which is our focus for this question, and we are having the equation of our patterns and sequences, which is also our focus for this topic. We also have the topic of functions and graph, finance, growth and decay, differential calculus and probability. So for the topics that we are focusing on, algebra and equations, it is weighing 17% of our paper. That is approximately 25 marks, and it is allocated question 1. And for the topic of patterns and sequences, it is also weighing 17% of our paper. That is 25 marks, and it is mostly found in question 2 and question 3. Now, this is our information sheet that we're going to find in our examination paper 1. And from this data sheet, we just need to identify which topics, which formulas are we going to work with, because we are going to look at question 1 and question 2. Then for question 1, this is one of the formulas that are going to be useful for us. So before I start my question as a grade 12 learner, I can go to my formula sheet and look at the topics or the formulas that are going to be forming part of each question. So this is question 1. And for my question 2 and question 3, I'm going to look at this one. I'm going to look at that formula. 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 So for question 2 and 3, which is patterns and sequences, I will be focusing on those formulae. And only for question 1, this is the formula that is provided for me in my information sheet. Now, the topic of algebra and inequalities. What are we focusing on here? So this is our checklist. This checklist, remember, this is a guide, and this is a list that we're going to utilize to say, have I acquired all of the concepts that are related or that are needed for me to work with question 1? So I'm just checking, did I acquire the knowledge in, or did I master all of these concepts that are forming part of question 1? So for 1.1, so we are going to say the first thing that I must look at it is to use factorization to solve quadratic equation in the form of which is our trinomial ax squared plus bx plus c is equals to 0. To say, am I able to use this zero factor law to factorize this? Am I able to use quadratic equation to solve quadratic equations? And they said you must remember to round off correctly to the stipulated decimal digits. Remember, it is mostly stipulated that we must go to 2, but it's not always the case. It can change. So we are going to check ourselves to say, do I have enough skills to work around that quadratic equation? So that is the part that we're looking at them. 1.3, am I able to solve equations where we are dealing with the sum and difference of 2 cubed involved? So solving for x, where we are now going to apply the factorization on sum and difference of 2 cubed. Right. Solving the side equations, am I able to work with the side equations by squaring both sides? And remember, we need to check the validity of the solutions here. So this is what we are dealing with, the side equation. So I am checking myself as a grade 12 learner to say, do I have knowledge around this concept? 1.5, am I able to solve the quadratic inequalities? And remember, when you're dealing with those inequalities, we are going to work with either a number line or we are going to work with the basic parabola. 1.6, am I able to work with the simultaneous equations when I'm solving for x and y, or any variable that they can give me, but two different variables using the two equations? Am I able to do that? 1.7, am I able to work with equations that involve the fractions? 1.8, am I able to work with complex equations where the substitution is necessary, like utilization of a K method? Here we are working mostly with the laws of exponents. So am I able to work with this? So this is where I check myself to say, okay, I can apply the laws of exponents where I'm dealing with the K method, or I can work with where I have the radicand, whereby I have a root, and where in that root is a variable, then I can make that root and the variable a K, or I can make where our variable it is given as an exponent, I can use the K method. Then am I able to work with the nature of roots of the quadratic equation? So here we are looking at nature of roots, right? 1.10, am I able to simplify exponential expressions and expressions involving radicals? So I'm working with those exponential expressions where I apply my laws of exponents and the laws that involve the solving of sets. Sets, remember, we're looking at where I have a root in that case. Then 1.11, am I able to now solve the non-routine problem? So these are the problem solving questions whereby I need to apply all of the knowledge that I have on algebra and equations, including my inequalities, to work with those non-routine problems. Now, grade 12, let us dive deep into our questions. We are going to look at the DBE November 2024. And for this question, grade 12, I will give you 15 minutes to complete from 1.1.1 until 1.1.5. And your 15 minutes starts now. Welcome back, grade 12. Let us look at question 1. 1.1. 1.1 reads as follows. Solve for x. 1.1.1, it says we have x into x minus 3 is equals to 0. Remember, we just need to know what is happening here. When we are looking at questions that involve the zero factor law, what I need to know is, do I have my equation in a standard form? Yes, I do. Is my equation factorized? I can see that the equation, it is already factorized for me, but if it is not factorized, I need to start by factorizing there. So standard form, I factorize. After factorizing, I will be equating to 0 in this case. That's why it's a zero factor law. Then I can proceed and apply the zero factor law to say x is equals to 3 or 0, or x minus 3 is equals to 0. Then in this case, I can just simplify this side, and x equals to be positive 3. So x equals to be 0 or x equals to be 3. So that is 2 marks that you're going to get there for each. Then we proceed to 1.1.2. 1.1.2, we are looking to solve for x, and they said correct 2 decimal places. So you can see that when they already inform us to correct 2 decimals, we are informed of utilizing our quadratic equation. So this gives us a clue to say we are going to work with the quadratic formula in this case. Now, to work with the quadratic formula, remember step number 1, I must have my equation in a standard form. To have it in a standard form, we must equate the other side to 0. So we can now see I can apply our additive inverse there, and I can subtract by 4x both sides. Or I can just say transpose the 4x, then I remain with 0 on the right hand side. Then on my left hand side, I remain with 2x squared minus 4x plus 1, it is equals to 0. So now this is in our standard form. We can apply the quadratic formula in this case, but to apply the quadratic formula, we need to know a. My value of a in this case is going to be 2. Remember, this must be given in the standard form ax squared plus bx plus c. So my a, it is the coefficient of x squared, which is 2. My b, it is the coefficient of x, which is -4. So B, it is going to be -4. So it goes with the sign. Then C, it is going to be +1. So the C is going to be 1 in this case. So I code down my quadratic equation from the formula sheet. Then I will substitute my A, B, and C. Then I get my solutions as. So to get my solution, remember, you punch everything in a calculator. The first solution, you punch it with a positive, write them before they root them. Then my second solution, I am going to punch my expression with a negative. So x equals to 1,71 or x equals to 0,29. So it is correct to do decimal places as I have done, write them, and that is going to be correct. So you're going to get a mark for the answer, then a mark for the answer. You get a mark for arranging a standard form and a mark for doing what? For substituting right there. So that's how you're going to get those 4 marks. Let's proceed to 1.1.3. 1.1.3, we have x squared minus 2x minus 3 is greater than 0. So what are we dealing with here? We are dealing with solving for x where we are dealing with an inequality. When we are dealing with an inequality, remember, the first thing that you need to check is, am I having my equation in a standard form? My standard form, it means I have all of the values on the left hand side, and on the other side of my inequality sign, it is 0. So do I have that? Yes, I have those already. The next step will be to factorize the left hand side. So to factorize the left hand side, I'm having a trinomial. When I factorize my trinomial, I have x minus 3. The second bracket, I'm going to have x plus 1 is greater than 0. But remember now, we are dealing with an inequality. So I cannot just apply the 0 factorial law. Because it's an inequality, I am going to look at my critical values. My critical values, it is when I take x minus 3, I just find x minus 3 is equals to 0. So this is the first critical value. The second critical value, it is going to be the second bracket there to 0. So it's x plus 1 is equals to 0. Then here we can see that x equals to 3 or x equals to -1. So my critical values are x equals to 3 or x equals to -1. So x is 3 from the first bracket and x is -1 from the second bracket. Then what do I do here? Remember, these critical values are the values that I'm going to plot on my basic parabola or on my basic number line. So I'm going to code down my basic parabola. X equals to -1, I plotted them, and x is equals to 3, I plotted them. Now I go back to my solution to say, what was the question requiring me to do? It said my equation, which is x squared minus 2x minus 3, must be greater than 0. Greater than 0, it must be above in this case. Now our x-axis. So when it's greater than is above, f at x is greater than 0 is above. When it's below, it is f at x, which is less than 0. So this is above because f at x is greater than 0 in this case, which is that equation of mine. So we can see we're looking for the solution that is above. So we can see that our function proceeds above on greater than 3 and also on less than 1. The solution proceeds there. So I can just have the lines, border lines here. I can have another border line. I can see my solution, it's from x, from 3 going up or from -1 going down. So we can see that my x is greater than 3 or my x is less than -1 in that case. So to provide that solution, we can say our x is less than -1 or x is greater than 3. Or we can write this one in a set Biller notation. I would say x is from the -infinity to -1, or x an element of 3 to positive infinity. And remember, this sign said greater than, it doesn't say or equals to. That's why I'm working with an open bracket, open bracket, open bracket. And if you can see my inequality sign, there does not have an equal in that case. So we can now have our solution as follows. So we're going to have a mark for the critical factorization. We are going to have a mark for the critical values, and we're going to have marks for each of the solutions there. Right, let's move on. Then we are going to question 1.1.4. We are still solving for x. Now 1.1.4, what do I see? The first thing that I see there, I see exponent. right? And I can see that my variable that I'm supposed to solve with regards, it is an exponent. So what is the first thing that I'm going to do there? I am going to start by applying the laws of exponent. To apply the laws of exponent, I will check, do I have my equation in a standard form? Yes, the equation is already in a standard form. I can straight and dive into my laws of exponent. When I go to my laws of exponent, I have 2 to the power 2x, and I'm going to come to this part and I'm going to break it down with regards or in terms of laws of exponents. Remember, laws of exponents says to you, if I have two bases that are multiplying each other, then I can take the base and I add the exponents as n plus b. So this is what I'm having there. So I can now see that from my equation, I am given it in this format. I can reverse and go back to that form. Then I will just simply separate into x to the power n and x to the power b. So what I do here, I will say x 2 to the power x, that is the first one, and I have 2 to the power 2 in that case, minus 32, right? Then as I proceed, I am going to let my 2 to the power x to become k, right? So what I can see that I'm having a complex equation to work with. So the best thing to do, as I'm having my x as an exponent, I'm going to apply the k method. So I'm going to say 2 to the power x is going to be my k. And when I do that, I am going to have the following. Whenever I switch to the power x, I replace it with k. So we can see 2 to the power 2x is going to be k, because 2 to the power x is k. All of this is k, right? Then there's a 2 there, then it's going to be squared in that case. Then you can see here, minus 2 to the power 2 is 4. Then 2 to the power x again is going to be k again here. So it's going to be 4k minus 32 is equals to 0. Then what do I now see on my left hand side? I have a trinomial that I can work with. Then I can just factorize my trinomial to say k minus 8 is going to be my first bracket, and I can have k plus 4, which is going to be my second bracket. All of those are equals to 0. Then k minus 8 is going to be, the first answer is going to be k minus 8 equals to 0, or k plus 4, it is equals to 0. Then k is equals to 8, which is what I'm having them, or my k, it is going to be negative 4. From that, k minus plus 4 in that case, from the second bracket in that case. But remember, we're not solving for k, we're solving for x. So I can go back and now replace k again with 2x. Then I can say where there is k now, I place back my 2x. So to say k equals to 8, I'm going to say 2 to the power x, which is now my k there, is equals to 8, or 2 to the power 2 to the power x 8 equals to negative 4, right? So we are coming back and to check, we're going to check why it's k 2 to the power x not equals to 4. It is because we cannot have the solution when we're having a negative right there. So we cannot even break this into our factors. And even if we can't break into our factors, even if I apply a log, we're going to get an error there. So we can now see that even if I say log, I say my base 2 of negative 4, this is going to be an error in that case. Even if you apply the laws of exponents, the laws when applied, because I'm going to have 2 to the power x, it's equals to negative 2 to the power 2, then the negative there won't allow us to apply the laws of exponent. That's why 2 to the power x cannot be negative 4, so we don't have a solution for the second part. But for the first part, I'm going to use the laws of exponent, and I say 2 to the power x is simply 2 to the power 3. So 8 is equal to 2 to the power 3. We have same basis. I can equate the exponent and x equals to 3. That's where I got my solution right there. Let's move on. Now, we are going to 1.1.5. So 1.1.5, what do I see? Grade 12s, remember, you must be able to see what type of a question am I dealing with, and you will know which procedures am I going to follow when I am working around that question. 1.1.5 says, we have a root of negative 2x plus 4. Outside of the root, we have minus x. And we are supposed to solve for x. We are dealing with a question that has what? We are dealing with a question that has sets. When you deal with a question that has set, the first step is to do what? It is to isolate the set. What does it mean to isolate the set? It means all of those numbers that are under a set, there must be one side, and those terms that are not on the side, they must be on the other side. So all of the terms under the side, one side, those outside of the side on the other side. So what am I going to do now? I am just going to take the negative x, I'm going to transpose it, or I'm going to apply the additive inverse of that negative x, and I'm going to have it on the right hand side. Then I'm going to have the root of 2x plus 4, so those terms are under the side, so they are on one side, and we've isolated the side, and we have the other terms as 2 plus x on the other side. Then after I've isolated the side, the step number 2, what am I going to do now? I am going to get rid of the side. To get rid of the side, I will square both sides. When I square both sides, I'm going to square all of those that are on the side, and I'm going to square both of x plus 2 plus x squared in that case. Then what I do in the following is that the squared will now solve the side. In that case, I will remain with negative 2x plus 4. It's equal to, I'm going to expand the right hand side, which is 2 plus x into 2 brackets, and I have 2 plus x again. Right, then I'm going to just distribute it nicely using my foil. Then when I distribute, I'm going to say 2 and 2 is going to be 4. Then I'm going to say 2 times x is 2x. Then I have 2x plus 2x is going to be 4x. Then x and x is going to be x squared. That is what I'm having on the right hand side. From here, I can now have it in a standard form. My standard form is to say all of the terms one side, and we're going to equate to 0 so that we can apply our zero factor law. Then what I do is the following. I will just say negative 2x plus 4 minus 4. So I'm going to now work with that 4. When I say negative 4x, applying the additive inverse of everything this side, minus x squared is equals to 0. Then I'm going to look for my next terms. I'm having negative 2x and negative 4x. I have negative 6x in that case. Then I have 4 and 4, they will subtract out. Then I have subtract negative, and I will have minus x squared there. It's equals to 0 for that part. Then what do I do from here? I can see that my x squared is a negative, and divide by negative 1 throughout. Then I have my x squared in the standard form plus 6x is equals to 0, which is what I'm having right there. Then from here, I can see I'm having it in a standard form whereby all terms are one side, they are equated to 0. I can apply my zero factor law. When I apply my zero factor law, I will start by factorizing the left hand side. Common factor here is x, so I take out x as a common factor. In my bracket, I'll remain with x plus 6. Then my x equals to 0, or x equals to negative 6. But remember, we are supposed to test for each solution. So I want to explain why is x not equals to negative 6. So what you do after getting the solution, because we're working with the sides, we need to plug it back into the equation and seeing if I am getting the correct answer. So let's say if x is equals to 0, I'm just testing will the left hand side be equals to the right hand side. So I'm going to have the root of wherever there is x, I have placed in 0 plus 4 minus 0, it's equals to 2. Then it's equals to 2. There's a 2 this side. Right. Now when I solve this, I will now have the root of negative 2 times 0, it is just 0. Then 0 plus 4 is 4. Root of 4, it is going to be root of 4. It's equals to 2. Root of 4 is equals to 2. Then 2 is equals to 2. Then we can see that this left hand side is equal to the right hand side. When x equals to 0, then 0, it is my solution. Then when I proceed for this question, I will come back again and substitute x is equals to negative 6. Now, let us look at a solution where x is equals to negative 6. So I substitute x equals to negative 6 in our original equation. So I'm going to have the root of negative 2 into our x is negative 6 plus 4 minus our x again is negative 6. It's equals to 2. So I just need to check, is my left hand side equals to my right hand side in this case? So let's look at the first part here. We are having the root of negative 2 times negative 6. We are going to have 12 plus 4 minus, so negative and negative is going to be plus 6. It's equals to 2. Then I'm going to check, it's going to be root of 12 plus 4 is 16 plus 6 is equals to 12. In this case, root of 16 is 4 plus 6 is equals to 2. 4 plus 6 is 10 is equals to 2. So 10 is not equals to 2. That's why x cannot be negative 6. So all the times when you're dealing with a sight equation, always test your final answers against the original equation to see if I'm getting the same answers on the left hand side and the right hand side. Now grade 12, let us move on to 1.3 and 1.2 and 1.3. And for these two questions, grade 12, you are given 10 minutes to complete 1.2 and 1.3. And your 10 minutes starts now. Welcome back, grade 12. Now let us look at 1.2. 1.2, we are required to solve for x and y simultaneously. Now let us dive into 1.2. Now to solve for simultaneous equation, remember, we will take one equation and make it equation number 1. The second equation, we're going to make it equation number 2. From here, I am going to derive the third equation. How do I derive the third equation? I derive the third equation from an equation that is easier to manipulate. When I say easier to manipulate, I have to check which variable is easier to make the subject of the formula, from which equation again. So I can see from my equation number 1, I can easily make y the subject of the formula because there's an coefficient of 1, it is raised to the power 1. So I can say from equation number 1, which is 2x plus y equals to 3, I can derive the third equation and say make y the subject of the formula. I can just transpose the 3, the 2x, and I'm going to have y equals to 3 minus 2x, and that is going to be my equation number 3. Now, because I've derived equation number 3 from equation number 1, I am no longer going to substitute back into equation number 1. I cannot substitute to an equation that I've derived from. So I'm going to now substitute equation 3 in equation number 2. To say whenever there is y, I'm going to substitute 3 minus 2x in equation number 2. So where there is y, and those are the parts that are going to be affected. So those are the two parts that are going to be affected. So I can see there was y squared. So in the space of y, I place in 3 minus 2x all squared plus x. Where there is y again, I say 3 minus 2x equals to 2. I can solve my left hand side first, and I can distribute this. I will have 4x squared minus 12x plus 9. When I also solve with this one, I will have the 2x squared plus 3x minus 2 in that case. So those are the values that I'm going to have in that case from simplifying the left hand side. Then I can now transpose the 2, or I can apply the additive inverse of 2 to say minus 2 both sides. Then I'm having the negative 2 right there. Then from here I can work with my like terms. My like terms are going to be negative 2 and 9. The squared, I'm going to have 4x squared and negative 2x squared. The other ones I'm going to have the negative 12 and positive 3. Then I'm going to say that 4x squared minus 2x squared, I have 2x squared. Then I'm going to have negative 12x plus 3x, I'm going to have 9x. Then I have my positive 9 subtracting the 2, I'm going to have 7. Then what do I see here? I see a trinomial. On my left hand side, I can factorize my trinomial into 2x minus 7. In the second bracket, I have x minus 1 is equal to 0. Then I say x from the first bracket, x is going to be 7 over 2. Or from the second bracket, I have x equals to 1. Then to find y, I'm going to say substitute x equals to 7 over 2. So substitute x is equal to 7 over 2 in equation number 3. Or again, substitute x is equals to 1 in 3, because I'm looking for y, and equation 3 already gave us y as a subject of the formula. But we can substitute in any of the 3 equations that we have there, or the 2 that we had from the original, or the one that we've derived is fine. Right. Then I can have my y whenever there is x, I put in 7 over 3 from equation number 3. So I can say 3 minus 2x, then x equals to be 7 over 2. Then I have my y equals to negative 4, or I can say y equals to 3 minus 2x, x is equals to 1, then y equals to 1. So the solutions are x 7 over 2, x equals to 1, y equals to -4, and y equals to 1. Right, now let's go to 1.3. 1.3, this is the problem solving question. It says consider the product, so we are having the product of 1 into 1 plus 1 over 2. We have the second product, which is 1 plus 1 over 4, and we have 1 plus 1 over 4. Each factor in the product is in the form of 1 plus n, for n is greater than 2. So this is our n. They say this n must be greater than 2. Determine all the value of n, which the product is going to be an integer value. So we are going to check where the product is going to have an integer value. So for us to have a product where there's an integer value, remember, an n will be an integer value if n it is found, it's either from all of the whole numbers from the negative side to say -3, -2, -1, 0, 1, 2, 3. So n is going to be an integer if it is any of those values and other values that came before here. So you can have 3 dots then to say continuous like that. So we are going to look for the values of n from that product. So let's check the first product to say when n is equals to 2. Remember, n must start from greater than 2. So the product is 1 plus into n, it is 2. So remember, this is my n because this 1 plus 1 over 2. So this is our n in this case. So my n, when n is 2, which is the 2, then I have 3 over 2. Right. Is 3 over 2 an integer? No, it is a decimal there. Remember, integers will be the whole number 3. So when n equals to 2, the product is not giving me an integer. Then I proceed. When n is equals to 3, so n equals to 3 here, I take this one, I proceed with when n is equals to 3. But remember, I'm dealing with the product. So when n equals to 3, I'm moving on to the second step. So I still multiply with the answer from the first question right there. So I still multiply the products again. When n is equals to 3, so our n is 3 then, I get the value is 2. So we can see that this is an integer. Then I proceed again. When n it is equals to 4, so my n is now 4. Right. When n equals to 4, I'm working with 1 plus 1 over 4, where n it is 4. In that case, remember, our n, it is the value where we are having 1 plus 1 over n, 1 plus 1 over 4. So when n equals to 4, in that case, then I'm dealing with the product. So the product is going to be the product of all of those that came before, which is 3 over 2, which is the one from the first part, multiplying by what? Multiply by 1 plus 1 over 2, which is the second one here. So I'm going to multiply by those two products that came before n equals to 4. Then my product, it becomes 5 over 2. The 5 over 2 is not an integer, it is decimals then. Then I proceed. So I can proceed with the same pattern to say I can have another term here as 1 plus 1 over 5, where n is now 5. So when n is 5, I'm going to have 1 plus 5. So this is where n is 5. Then I can now multiply the products of those values that came before, or those terms that came before. This is this term, that term, and that term. So this is all those 3 terms. I multiply with them because I'm looking for the product, and I can see it is 3 in that case. So we can proceed with this pattern over and over again. When I proceed with this pattern, what am I seeing here? Let's go and analyze this one. What do I see is the following. I only have n to become an integer value when, or I have the product to be an integer value when n it is 3. So I'm having an integer when n is 3. I'm having an integer again when n is how much? When n is 5. So what do I see here? I can see n is an element of 3, 5, 7. So n it is what? N is has to be an odd number, because every time, let's go back to this, every time my n it is odd, so that is my n then, I'm having an integer value. So when n it is odd, I am having my integer value in this case. When n is even, I'm having decimals. So what does this mean? So n is an element of all of the odd values. So that is to say, n must be an odd number. However, n must be greater than 2. Why are we saying n must be greater than 2? We are looking at that restriction here, and we are going to look at when n is 2. When n is 2, I'm not having an integer value. So n being 2 is not involved or is not included. We are now saying n must be an odd number. It must be greater than 2 because 2 is even and 2 does not give us the solution. Right. Now, grade 12, let us now proceed to our second topic. So we are going to look at the sequences and series. Let us start by looking at our checklist for the sequences and series. Now, for our checklist, the first thing that we need to check ourselves to say, am I able to solve problems involving arithmetic sequences? So here we need to be able to find the arithmetic formula from the formula sheet again and utilize it to solving problems. So you're going to check yourself as a learner to say, okay, yes, I am able to work with arithmetic sequences. I have no problem there. So I am preparing for my examinations. I am checking all of the key concepts that I need to acquire for the particular topic. So this checklist is very important. It's going to be very fruitful for you to know if you've covered everything that you need to cover for the examination. Number 2.2, am I able to solve problems involving geometric sequences? So am I able to work with geometric sequences? Am I able to apply the formulas around geometric sequences? So I'm checking myself to say, yes, I am able to work with that. Remember that formula again, the formulas around geometric again, they are found in our information sheet. 2.3, am I able to solve problems involving quadratic sequences again? So am I able to work with those quadratic sequences? Yes, so I am checking myself to say, do I have all the required knowledge and skills that involves the quadratic sequences? I proceed. Am I able to solve the combined sequences whereby maybe the odd numbers terms are arithmetic, the even numbers terms become geometric, or either way, right? 2.5, am I able to solve problems using the sum of the arithmetic where prove that, am I able to prove the Sn, the sum to arithmetic in this case, where we are saying this Sn represents the sum or to n terms of an arithmetic series. So we need to know the proof, and remember the proof we can say this is our book work, this is what we must practice in our books, and we must have in our activity books. Again, am I also able to prove the sum to a geometric series to say, prove that Sn is equals to a into r to the power n minus 1 all over r to the power, or r minus 1 where r is not equals to 1. And am I able to say this one, this my Sn is represent the sum to n terms of a geometric series? So am I able to work around those proofs? Remember, these proofs are also examinable. Let us move on. Am I able to solve again problems that include now the series, arithmetic series? Am I able to solve problems that include the geometric series? Again, we are proceeding. Am I able to work with geometric series where it converges? So you must work with those convergent geometric series in this case. So here we will also look at the sum to infinity issues there, or problems. Am I able to solve problems involving the convergent geometric series where we are dealing with the sum to infinity? So this is to say, I'm checking to say, am I able to work with those convergent geometric series where we are having a sum to infinity? Am I able to solve problems involving the sigma notation to say, I am evaluating the sigma notation for both arithmetic and geometric sequences? Am I able to now take an arithmetic and geometric series and write it in a sigma notation? So this is two things under sigma. Sigma, you are given the sigma, you are going to evaluate the sigma, whether it is arithmetic or it is geometric, or you are given an actual series, you have to represent that series, whether it's arithmetic or geometric, in a sigma notation. Number 2.13. Am I able to solve practical problems involving the sequences and series? So this is where I take my knowledge on sequences and series, I apply it to a real life problems. I apply it to practical problems. Right. Now, grade 12s, with that in mind, let us now look at 2.1. So we're going to look at 2.1.1 and 2.1.2. And for these two questions, grade 12, I will give you 8 minutes to complete these two activities. And your 8 minutes starts now. Welcome back, grade 12. Let us look at 2.1. 2.1 reads as follows. The first term of an arithmetic series is 7, okay? First term of an arithmetic. So we are told the type of a series that I'm working with, it is arithmetic. So we have A, it is equal to 7. And we are told that the common difference of this series D, it is 5, okay? That's important. And the series contains 20 terms. Oh, nice. And it is equals to 20, right? It says calculate the sum of this series. Let's go to 2.1.1. Remember, we've established that our A, it is 7, our D, it is 5. We are told that N, it is 20. So what are we supposed to do here? We are going to code down the sum to the series. Sum to the series, it is arithmetic. So I'm going to take the sum to the series for arithmetic. And I'm going to substitute my values of A. When there's A, I place in 7. When there's D, I place in my 5. When there's N, I place in the 20 there. So Sn, so sum to 20. Punch everything in my calculator. Then sum to 20 is going to be 1090. Now let's proceed to 2.1.2. Let's come back to this one. They said the original series is extended to 70 or 75 terms. And the sum of these 75 terms, it is 14,400. Using the sigma notation, write down the equation of the sum of the terms that are needed to be added to the original series. Let us read the question again. Remember, grade 12, you must be able to read the question more than once so that you can understand it in detail. Let's start again. The original arithmetic, it is extended to 75 terms. The sum of all of the 75 terms is now 14,400. So we have to use the sigma notation as our representation. So whatever we are going to deal with here, we are going to represent it using the sigma. Write down the equation for the sum of the terms that were added. Or we're not looking for the equation of everything, we're only looking for the ones that were added. Now, let us start here. Let us start by finding the general term for this one. So our general term, remember from the previous question, we have established that A was 7. We know that our D was 5 in that case. So we can find our Tn to say Tn of an arithmetic. It is going to be A plus into N minus 1 D. Right. Then what I have then, I can now simplify my Tn to become 5n plus 2. Why am I writing my Tn down? I am writing the Tn down so that I can be able to now have my series in this case. To have my series in this case, I am going to look at the series from T21. Remember, the first terms was from n is equals to 20. So I need to know from 20 to 75. How many? The equation for this one that I have added. Remember, I'm not looking for the whole series from 0 to 75. I am looking from 20 to 75. So I'm going to start from T21 until T25 in this case. From T21 until T25, we know all of them. This is the total. So this is T75, which is all of them, or SN75 in this case. So this is SN75, and this is sum to 20. So to find the difference between 75 and 20, I need to just say sum to 75 terms, all of the terms is 14,400, subtracting sum to 20. So this is S to 75, subtracting sum to 20. This is going to give me 13,310. Why am I doing this? It is because I am looking for the equation of the added terms to the original, not the equation of all of the terms. Right, so that's why I have to work around it in that way. Right, then I get my sum to be 13,310. Now I need to know this 13,310. Remember, this is Sn of what? It's S of 75 subtracting the S of 20, which is actually S55 in this case. So we're working around sum to the 55 terms. So I can now check, okay, from my T20 until my T75, I'm looking for the terms, the actual terms now. Now the actual term is T21. I'm going to go back to my general formula. I'm going to say T21 is equals to 5 into 21 plus 2. Then this is going to be 107. Then 22 again, I substitute n equals to 22 there. T22, I will simply just say 5 times 22 plus 2. This is 112. Then I go and check my T23. So I'm going to T23 in this case. So what am I doing now? I am now looking for the actual sequence. Then T23 is going to be 5 into 23 plus 2, and I get 117 for that one. Right. Therefore, I can now find, remember, I am now having from T21 and T227. This is the sum to 55. Remember that. Now I'm looking for the general term of the sum to 55 right now. Why 55? Remember, I am looking for the equation for the sum of the terms that were added. Right. Then I can say my Tn equals to A. My A for the one that were added, it was 107. So I'm having a new series from T21 until T275. The first term there's 107. Then my D. So when I subtract the 2, I get 5. I get 5 again from 117. Subtracting 112. Then the D, it is equals to 5 in that case. Then my Tn, it is now 5n. It is 5n plus 102. Remember, I am working with a sigma notation because I'm representing terms of sigma. Sigma requires Tn here. So that Tn, it is going to be that part right there. Right. But it's our Tn, and we are starting from n, it's equals to 1. And we are going to the last term of 55 because the added values from 75 minus 20, we get 55. So then my sigma is going to be, last value is 55, n is equals to 1. We are starting from 1 there, that's what I'm working with. Then my Tn, for those added ones, it is 5n plus 102. So you must see the difference between the added and the total in this case. Right. Now grade 12, let us look at 2.2. So for 2.2, we're having 2.2.1 and 2.2.2. And for these two questions, you are given 10 minutes to complete these two questions then. And your 10 minutes starts now. Right, welcome back grade 12. Let us look at 2.2. Now 2.2 reads as follows. The sequence of the first differences of a quadratic pattern is, okay, is 1, 3, and 5. So we have a quadratic. And in my quadratic, I'm given the sequence of the first differences. And remember, on our quadratic, the first differences, what are they giving me? They're giving me arithmetic. So you must remember that to say this is going to be an arithmetic sequence. If T99 of this quadratic pattern is 9,632, calculate the value of T98. Okay, this is interesting. Right. To find the value of T98, we are going to work with the following. We are going to look at the quadratic pattern and check how the quadratic pattern behaves. This is how it behaves. So we have 1, we have 3, we have 5. Continue, we are going to have the values like that. So we are told that the T99, so this is my T99. My T99 was 9,632. Right. So I need to find what is T98 here. What is this value? Right there. Now, what you see is the following, that T1, it also becomes our first differences here. It is going to be this T1 again, corresponds to T1. Again, T2 goes with that. So we can see that there's a nice relationship in terms of the values in the quadratic and in our arithmetic in this case. So the first thing that I need to do is the following. If I can find the value of the first difference between T2 and T1, if I find that value, I know that this value will be found the first between the two, then the second difference will be found between the T2 and T3. So I'm going to use that knowledge to say, okay, I can go back here and actually say I need to work around T98 minus that. I must get what is this value, and I can find the first difference before I get to T98 there. And I find the value after the T98 right there. So I'm going to work with my Tn to say, okay, I'm going to consider my sequence as arithmetic. Then my A, it is 1. Then my D, it is 2. So when I subtract further here, you can see this is 2 and 2. Then when I work at arithmetic then my arithmetic is going to be Tn equals to 2n minus 1. What did I indicate in the beginning to say? T1, it corresponds to the first term on the differences. T2 corresponds to the second term. So if I want to know what is T98, the T98 will also correspond to the T98 also on our differences in that case. So that's what we are looking at in this case. So we can see that T1 is T1 on the arithmetic, on the quadratic, which is the first sequence, corresponds to T1 on the arithmetic. The same thing that we're going to deal with here is to say T98 on the original will also correspond to T98 on the arithmetic, which is on our first differences. So what we're going to say is the 98th first difference, it is going to be what? So I'm looking for this value right here. I have its general form. I'm going to say Tn is equals to 2 into 98 minus 1, which is none than 95. So the value, the first difference that I get here, it's going to be 195. So that is what I am getting from that. To say the term value, it corresponds to the value, again, the term value on the differences, right? Then what we proceed with is the following to say, for my quadratic, to find T98, what do I do here? I am just going to reverse the two parts there, right? Let me just rewrite that so it becomes clear. So what I did here, what we did is we had T98, and we also had 9,632. So it proceeds in that fashion. So to say, what we did is we have found the value of the first differences, which is now 195. And remember, this we have used the fact that the first term on the original, it is also corresponding to what? The first term on our arithmetic, which is the first differences. So we can see that if this is T2 and this is going to be T2 for the difference, I'm not saying the two values are equal, I'm just saying they correspond to say term number 1, we have the term number 1 on that part. So if I say I'm looking for T98, that means the differences that I'm going to get, the first difference I get on the T98, it is also the T98 of the differences in that case. So this is also going to be this is T99, this will also be T99 of the differences in that case. Now, to find the T98 now, because I found my T98 from the arithmetic, which is 1, 3, and 5, then I can reverse the process and I get my T98. So from the quadratic, I'm going to say T98 equals to 9,632 subtracting 195, and I'm going to get how much? My T98 is going to be 9,437. So what's important here is to know that the first term of the quadratic, it corresponds to the first term of the arithmetic. So if I have a value in arithmetic in my quadratic as 50, for example, that means that value as 15 on my first differences, it will also correspond as 50 as the first term of those differences there at 50 there. Right, let's proceed to 2.2.2. It is further given that the third term of the quadratic pattern is 32. Determine the general term Tn of the quadratic pattern. How would you find the Tn of the quadratic? We have to reverse the process. How do I reverse the process? I am going to work with what I started with. Let me just go back here and so we can do it. I had 1, I had 3, so these are my differences. I had 3. Okay, let's write it again. I had 1, I had 3, I had 5. Right, so what I have here, this corresponds like that. Right, so this is how it follows. So we know this is 2, the difference here is 2, the difference is 2. Or if you proceed again, we can see that this value here is going to be how much? 7. Then the difference again is going to be 2. We were told that it is given that the third term of the quadratic. So on the main term, on the main quadratic pattern, we have 32, which is the third one. So T1, T2, and T3. Now T3 here, it is given as 32. So we are told that this is 32. So my job here, it is just going to be to reverse and go back to the other terms in this case. So what we're going to do here is the following. We're going to say 32 minus 3, we get 29. So we're going to say 29, then we're going to say 29 minus 1, we're going to get 28. So that is how the pattern is going to proceed. So we're just going to reverse and go back to the first 3 terms. So that's what we are going to start by doing. So, and that is what we are having them. We are going to have 28, 29, 32, and we are having our differences as 1, 3, 5, and 7. Then we know that my 2a, when I'm working with quadratic, is equal to that. Then we have 3b plus, or 3a plus b equals to 1. Then we have a plus b plus c going to be equals to 28. So that's what I'm going to deal with here. So to find my a, I'm going to say 2a is equals to 2. Remember, the general term of a quadratic, it is Tn. It's equals to an squared plus bn plus c. So I'm looking for a, b, c. Right, then my a is going to be 1. To find my b is going to be 3a plus b equals to 1, which is the first term of the first differences. Then I substitute a equals to 1. Then I solve for b. My b is going to be negative 2. Then to find my c, I'm going to say a plus b plus c equals to 28. Then a, it was 1. Then b equals to negative 2 plus c equals to 28. Then my c is going to be 29 in this case. So from my general term for quadratic, which is Tn equals to an squared plus bn plus c, then I substitute my a. My a is going to be 1, where b equals to negative 2, then c equals to 29. That is my Tn right there. Now, grade 12, let us proceed to question 3. And for question 3, grade 12, you are given 10 minutes to complete question 3, and your 10 minutes starts now. Welcome back, grade 12. Let us look at question 3. Question 3 reads as follows. A circle with a radius of 6 centimeters, it is drawn. A second circle, which is a smaller circle, it is drawn through the center of the first circle. Okay, so the bigger circle here, it is a radius of, so the center, 6 centimeters. So this, from here to there, it is 6 centimeters. And the smaller circle is drawn through the center of the first circle. So the second circle here, it is drawn from the center, right there. And also touches the first circle internally. So it touches internally at that point, as shown in the diagram. A third circle, which is the smaller circle, is drawn through the center of the second circle. So the center of the second circle, we are drawing the third circle right there. So that's what we are having for those questions. The process of drawing the circle continues and forms a geometric pattern. Keyword them. We are looking at a geometric pattern. Write down the radius of the third circle. Okay. Let's look at 3.1. we were told that the first circle, the radius was 6 from here to them was 6, right? Then the second circle, the radius of the second circle again, so it is drawn, we have another circle drawn through the center. You can see that the diameter of the second circle, by the way, it is going to be 6. The whole diameter is 6. Then the radius of the second circle is going to be 6 divided by 2, so it's going to be 3 and 3. So what we're seeing is the following. Second circle, we are going to have its diameter as 6. So the second circle, so I can show you them. The whole diameter there, it is 6. Then its radius is going to be 3 and 3. Now, when we proceed with the same order in that case, we see that the radius of the second circle, it becomes the diameter of the third circle. So what do we see here? From the third circle, that radius, which is from here to them, it is 3. It becomes the diameter. Then what is going to be the radius of that third circle? It is going to be the 3 divided by 2. Then the radius of the third circle is going to be 3 over 2, which is 1,5. The answer is going to be 1,5 there for that 2 marks. Now let's look at 3.2. 3.2, it says, calculate the sum of the areas to the first 10 circles. Now, to find the sum of the areas of the first 10 circles, what are we going to look at? We know that area equals to pi r squared. And we are going to say our areas is going to be pi r, the radius of the first circle. So this is the radius of the first circle, r2, the radius of the second, and r3, the radius of the third. Remember, the radius of the first circle was 6. We found the radius of the second circle, it was how much? It was 3. Then the radius of the third circle, we found it as 3 over 2. So that is how we're going to proceed with those equations then. So we are using the sum to the areas. So that means it's going to be pi r. The r1, the radius one, is going to be 6 squared. The second one is going to be pi r squared, which is the radius of the second one, which is going to be the 3. The radius is 3. Then the radius of the third one is going to be, area of the third is going to be pi r. The radius of the third is 3 over 2 squared. Then the area is going to be 3 squared is 36. 6 squared is 36. And that is 36 pi. 9 pi. And 9 pi is going to be 3 squared, which is 9. 9 times pi is 9 pi. Then we're going to be having the third one as the radius is 9 over 4, which is 3 over 2 squared, which is 9 over 4 pi. Then we're going to now look at, because we're looking for the sum to the areas, then we're going to have find A. Our R is going to be what? We're going to say R is going to be 9 pi over 36 pi. Then pi and pi will divide out. Then R is going to be 1 over 4. Why are we using R? Remember, we're told this forms a geometric sequence. Right. Then our A is 36 pi. Then our N, because they say to the first 10 circles, our N, it is equals to 10 in that case. Then we're going to quote down our Sn for a geometric. Then we're going to place in our values where S10, N equals to 10, then A equals to 36 pi into 1 over 4, which is our R, all raised to the power N. N, it is 10 minus 1 over R minus 1, which is 1 over 4 minus 1. Then our sum, when you press everything in a calculator, it becomes 150,80. And that's how you're going to get your 4 marks. Right. Let us look at 3.3. So for 3.3, it says, which circle has a diameter of 3 over 128? Right. So we're looking for a circle that has a diameter of 3 over 128. But remember, we are given the radiuses from our, or we're working with the radiuses from our previous questions. So we can still work with the radius, but we are going to now work around the radius of this diameter. So we are going to say the radius of this circle with the diameter of 3 over 128 is equal to half. So remember, the radius is half of the diameter. So my diameter was 3 over 128. Then the half of it is going to be 3 over 256. Then this is the value that I'm going to work with on my series then, on my sequence then. Why am I working with 3 over 256 instead of 3 over 128. 3 over 128 is the diameter, and my sequence, it is working with the radiuses, so I had to get the radius of that diameter. Then I can see that I am looking for the circle, so we are going to now say term 1, term 2, term 3, which is the radius of the first 3 circles, to the very radius of the last circle. So what I'm going to look at, I just need to know the position of the radius of the last circle in this case. So R, going to find our R is going to be 3 divided by 6, which is 1 over 2, A equals to 6. Then my Tn is going to be 3 over 256. I just need to know what is the position of this Tn value in this case. Then I'm going to work with my geometric to say Tn is equals to A times R to the power n minus 1. Then I start between my values. My Tn, I've already established to say my Tn is 3 over 256. I just need to know what is the n of 3 over 256. Then if I can find that, then I will know which circle is this one. So from this question, we are looking for n. Then A is equals to 6. Then R is 1 over 2 all to the power n minus 1. Then I can solve for n from here. Then I can divide by 6 both sides. Or I can just say, let us just multiply by 1 over 6. Multiply by 1 over 6. Then on my left hand side, I get 1 over 6 times 3 over 256. I get 1 over 512. It's equals to 1 over 2 all raised to the power n minus 1. Then what do I do from here? I can work with the loss of exponent where I'm trying to have the same basis in this case. And if I work with the loss of exponent here, I have 1 over 2 all raised to the power 9 in this case. Because remember, this is 1 over 9, 1 to the power 9 over 2 to the power 9. This is going to be 1 over 512. So that is going to assist me in finding my answer there. Then I can see I have the same basis. I can just equate the exponent. Then I can see that n minus 1 is now equals to 9. So I just equate my exponent. Then my n is equals to 10. So the 10th circle will have the diameter of 123 over 128. And this brings us to the end of our lesson, grade 12. Join us on our next lesson. For our next lesson, we are still focusing on mathematics paper 1 revision. We are going to look at the second part of our revision, and for the second part of our revision, we are going to cover the topic of functions and graph, and we'll also cover the topic of finance, growth, and decay. Thank you. Enjoy the rest of the day, and all the best for your final examinations.